NASA just crashed a $300 million spacecraft into an asteroid. Why? To save us from the apocalypse. Haven't you seen Armageddon?
It's the size of Texas, Mr. President.
We didn't see this thing coming?
Alright, no, full disclosure, this asteroid wasn't on its way to obliterate Earth. It's still 11 million kilometers away, and there was no risk of it running into our planet. But this collision was part of a mission called the Double Asteroid Redirection Test, and the goal was to help test out our planetary defense systems, to see whether we could knock an asteroid off its trajectory if it was hurtling towards Earth. And it worked. Aside from getting some amazing live-streamed footage, NASA also got a lot of great scientific data on how to protect our planet, so that if we ever find a killer asteroid set to collide with Earth, we know how to stop it, or at least nudge it out of the way. We might have just found our Get Out of Apocalypse free card. NASA describes the DART mission as a test of, quote, kinetic impactor technology, but it's essentially the Hulk smash of space science. On one side, you have the DART spacecraft, which is about the size of a small golf cart or a vending machine. On the other side is the target, a little asteroid moonlet called Dimorphos. It's 160 meters or 520 feet in diameter, and it orbits around a larger asteroid called Didymos, both of them forming a binary asteroid system, a little dancing pair that orbits around the Sun every 2 years. They go from being out past Mars to coming relatively close to Earth. Well, close in space terms. It might look like a close shave with our planet, but when DART made impact, Dimorphos was still 11 million kilometers or just under 7 million miles away from Earth. But even though this impact happened a long way away, we still got to see it all go down on a live stream.
We're seeing Dimorphos, so wonderful, wonderful.
That point of light that's slowly getting bigger is the binary asteroid system. As we got closer to impact, we started to see more details of the asteroids come into focus. Those images came thanks to the single instrument on board DART, the Draco camera. That stands for Didymos Reconnaissance and Asteroid Camera for Optical Navigation, NASA and its names. Draco helped navigate DART towards its target, taking high-resolution images of the asteroid on the way. In the final moments before impact, those images beamed back to us, showing amazing detail on these ancient rocks. Then at 7:14 p.m. Eastern Time in the US, here on Earth, we got confirmation of impact.
Oh, wow.
Awaiting visual confirmation.
All right.
And we have impact. A giant leap for humanity in the name of planetary defense.
Woo. Fantastic.
It was incredible to see how so many years of hard work and creativity resulted in a direct hit of Dimorphos. Was just an adrenaline rush. I'll add that I've been at the lab now for quite a few years, and I've been involved in a lot of missions and achievements, and never before have I been so excited to see a signal go away and an image to stop.
The final image was taken just 1 second before impact, 6 kilometers above the surface of Dimorphos. DART crashed while the image was being transmitted, so that's why most of it is blacked out. NASA later released a sped-up video stitching together the final images from Draco. Scientists expect Dimorphos's orbit will change by about 1% after the impact, but telescopes on Earth will measure that change exactly over a number of weeks. In fact, the Atlas project in Hawaii has already used its telescopes to capture images of the DART impact and the resulting debris. Timing this whole thing was a complex game of orbital physics, and if you're keen to know more about the planning and the background to the mission, I actually interviewed the DART coordination lead from the Johns Hopkins Applied Physics Laboratory for another video. I'll link to that in the description below so you can check it out after this. Oh, and while we're at it, just to answer one of the big questions and comments that I got on that video, no, NASA didn't knock the asteroid out of orbit and into a collision course with Earth. That would have been really dumb. NASA and the Johns Hopkins team spent a lot of time with their protractors and rulers and calculators making sure that that didn't happen. But you know what? If our planet explodes in a week, I owe you a Coke. But back to the impact. I know what you're thinking. If the space probe crashed into the asteroid, those instruments are cactus, right? We won't get any more visuals or data. DART was our last hope, right? No, there is another. 15 days before DART crashed, it deployed a small CubeSat made by the Italian Space Agency, ASI, called LiCiaCube. About the size of a toaster, LiCiaCube was sent up to take images of the DART impact after the crash. Its job was to use an onboard RGB camera to study the ejector cloud and the impact crater from the crash. Because LiCiaCube doesn't have a large antenna, those images need to be downlinked to Earth one by one over a number of weeks. They want as much detail as possible. After all, how many times do you get to play Demolition Derby up in space? And these images are actually set to provide a lot of valuable data to scientists about the asteroid and the impact. DART didn't exactly blow the asteroid to smithereens. Remember, DART is about the size of a small golf cart, and the asteroid is the size of one of the Great Pyramids. But still, it was travelling at more than 22,000 kilometres or roughly 14,000 miles an hour before impact. When it hit in the vacuum of space, that was enough to knock the asteroid off course. So if Dimorphos didn't pose a threat, then why spend $300 million to crash into a harmless asteroid? Well, because the not-so-harmless asteroids could still be out there. According to the mission team at the Johns Hopkins Applied Physics Laboratory, we've found 90% of the asteroids near us that are a kilometre or larger in size. Scientists are tracking those, but the smaller asteroids, a few hundred metres across, like the size of Dimorphos, we found less than half of those, and they could cause enough damage to wipe out whole towns or cities if they impacted Earth. Thanks to this mission, we now know a lot more about what it takes to target these kinds of asteroids and protect our planet. So I guess I'm crossing asteroids off my deadly fears list for now. Thanks, NASA. Alright, that's it for me for now, but if you want to check out more on the DART mission, be sure to check out my previous video where I speak with the mission lead and dig into the science of space physics. Or for another big mission explainer, why not take a look at my behind-the-scenes visit to the NASA factory where they built the Artemis rocket. That was a lot of fun. And while you're here, chuck us a like, why don't you? And remember to subscribe for more space news as it happens. I'm Claire Riley, official Smashing Into Space Rocks reporter for CNET.